So a large organization, for instance, let's take Netflix. I guess I don't have an exact number, but they at least have more than 1,000 software engineers. In comparison, we have 12. So there is a big difference between large organizations and startups. And unfortunately, there exists no golden rule that you can easily apply them. So instead, you have to deal with a lot of trade-offs along your way. Next slide, please. Before I go into our journey details, let's give you a little brief overview of what we're doing. So my name is Susanne Kaiser. I am the CTO of Just Software. We are a startup located in Hamburg. And at Just Software, we developed Just Social. That's a B2B solution providing apps for collaboration and communicating to support teams working together more efficiently. And the next slide, please. And before I explain why we introduced as a startup with very less resources, why we introduced microservices, I will take you on a journey to our beginning. So at the very beginning, everything was one single unit in every aspect. So we were one team working on one collaboration product implemented as one code base based on one technology stack. Next slide, please. And after a while, everything evolved, which is quite well, but it's quite fine because we added more and more features to our product, and our number of users increased, and the team was growing. So that's supposed to be fantastic, but instead we reached a point, approximately 1.5 years ago, where everything felt kind of clunky. Everything was kind of tied together. So from the organizational perspective, it took quite long to get things done. So discussions, meetings, or decisions. And we had no really clearly assigned responsibilities. So it took a while. Someone felt responsible for a specific action. For example, when a bug arises, so who takes the responsible to analyze and fix it? So our processes were kind of slow, and our productivity suffered. And from the product perspective, we were continuously adding more features on top of it. And so the user experience and usability suffered from the continuous feature amendments, because instead of solving our users' problems in a very easy way, we were constantly or increasingly confusing them. So, and from the software architecture perspective, it was not very easy to add new features without affecting the entire system, and also not to release those changes that we did without rebuilding and redeploying the entire system. So there evolved a kind of need to split and shift things. Next slide, please. So product-wise, that was 1.5 years ago. We established the vision to divide our one product, our one big ball of mud, into single apps, and each of them taking care of a specific use case and solving one problem, and this one very well. So we split our one product into several collaboration apps, taking care of document sharing or task management, or an app for real-time collaboration, and also for exchanging or sharing corporate news and information with an enterprise social network. Next slide, please. Organizational-wise, we divided our one team into smaller multiple teams, and with the goal to establish autonomous cross-functional teams with well-defined responsibilities. So we want our teams to work on different parts of the systems, independent from each other at a different speed, and with minimal impact across the teams. We assign to each of these teams specific collaboration apps, so that they can take care of it of these collaboration apps and develop and deploy them at their own speed. So we want to release changes independently as well, and and without affecting the entire system. To gain autonomy, we have to get rid of these dependencies, and to achieve this, we have also to cut ropes within our software architecture. So in the long run, we wanted to introduce microservices, after we have partitioned our product into a single app and split our one big team into smaller ones with well-defined responsibilities, the logical next step was to introduce microservices to also gain autonomy and flexibility in our software architecture as well. Next slide. So this looks very easy at first glance, but it's a lot easier to say than do, because microservices, next slide please, come with a lot of complexity that might not be obvious at first glance. So in a distributed system, all your microservices are communicating over a slow and unreliable network. And this means that your services can fail at any time. And you have to establish a mechanism to make your system resilient. And so you had to add complexity to handle partial failure in your system. And since microservices are dealing with partitioned data, you are losing consistency in a distributed system. You also have to take care of handling eventual consistency in your system. And since your operational complexities increases because you have to deal with more moving parts, you have to add complexity to monitoring and deployment as well. And since your microservices are communicating over an API, you have to consider and refer to it in your testing phase as well, with consumer-driven contract checks, for example. And with all these complexities is that your skill set is totally different than implementing a microservice. And this is kind of like expensive on the one hand, because you either have to learn the new skill set, or you hire someone or hire some consultants, for example. And another thing that you have to reflect is how to handle authentication and authorization. And another aspect is the development environment, because you don't want your developers setting up all your services. Instead, you want to have an easy access so that they can develop their services smoothly. Next slide, please. So untangling the monolith is hard work and very time consuming. So this development process is at first slowing down. It's getting worse before it's getting better. And the transformation process itself takes far longer than you originally anticipated. So at first, when we introduced them, we missed a milestone. And that's the reason why you have to take care of those complexities and take your time to get your skills up to that you can run a microservice in an ecosystem. And if you're dealing with core functionalities with a lot of dependencies, it's very hard to untangle all these dependencies. And you can leave aside that you still have running system that you still have to maintain and take care of. So if you look at all these complexities and challenges of microservices, you might ask yourself, well, shall I introduce a microservice architecture or just stay on a monolithic architecture? Well, and it depends. It depends what you want to achieve. And it depends on what situation you are. And for us, it was the journey to microservices was not only technical driven, but it was organizational and product driven. So we first divided our product into single collaboration apps, and then also on our one team into multiple smaller teams with a goal to establish autonomous teams. So, and we want to assign to each of the teams well-defined responsibilities so that everyone can work efficiently on their own responsible services. And in addition, we want to develop and deploy independently. So each team should have the capability to implement it and to deploy it at their own speed and rate without affecting the entire system, and also without affecting the other teams, and to release changes quickly. So that was our motivation, why we introduced microservices. And after you have decided, well, next slide, please. Let's start with microservices, but how? How shall we start with microservices? So you have your big ball of mud, and you try to decompose microservices out of it. And So what we then derived was a kind of transformation process consisting of different parts. The first one is to identify candidates, which are good candidates for microservices. The second one is the decomposition process itself. And the third one is to establish the microservices ecosystem. They don't have to go sequential, they can also be in parallel as well. So let's start with identifying candidates. And before we do it, next slide please, we have to consider the key concepts of modeling good microservices to achieve the main benefits out of microservices. And these are the loose coupling between the services and high cohesion within a service. So, no, sorry. So when services are loosely coupled, a change of one service shall not affect the other services, and you make changes easily. You can make changes easily to one service and deploy it without changing the entire system. High cohesion is reflected by related behavior shall sit together. So when you change this behavior, you want to change this behavior at one single point. If you have to change it at different parts of your system, you have to redeploy all these services that are related to this behavior, and then your deployment process is coupled again together, and that's something that we don't want to achieve. So these are the key concepts that you have to keep in mind to identify candidates for microservices. So next slide, please. This related behavior is usually reflected by bounded context. We have heard of it before. It's a pattern of the domain-driven design, and it's reflecting the specific responsibility for a well-defined business function, a well-defined business capability. Thank you. Okay. It's half automated. It works. Miracle. So in our case, we used our collaboration apps working as bounded context, as the coarse-grained service boundary, and from that point, we can go into finer-grained services as one afterwards. So, and now the next part of the transformation process starts, the decomposition of the microservice candidates. The first approach that we did is that we established a coexisting service from scratch, and we used our Drive app, collaboration app, with taking care of document sharing. I'm spoiling it, it was not a good idea, but generally speaking, there's nothing wrong with creating a coexisting service from scratch, but I will get to the disadvantages in the next slide. But what we did in this one is, as a coexisting service, we were creating it from scratch and established a document sharing service itself, which has the data authority over documents. And so just Drive itself owns the data authority over documents, and each document has an author assigned. And the author itself, it's still stemming from the profile management, which is still kept in the monolith itself. So the next question arises, so whenever we display a document, shall we then request the author information directly from the monolith, or shall we then keep it redundant in our Drive app? So that's what we did. We kept redundant data of the profile information in our new service, and to keep it in sync, we've established a message broker that the monolith itself is then publishing modification events to whenever a profile data has been updated, so that the microservice, the new one, can consume it and update its redundant data accordingly. Well, to be honest, it was a very heavy undertake because we did all at once. As I was mentioning before, it was not an exact equivalent of the existing service. Instead, we added more features in the same process step, and we introduced a totally new data structure because we also wanted to cover some specific requirements as well, and also a new user interface to improve the user experience itself. And in the meantime, we still have to maintain and run the current system. So this took a long time and was kind of frustrating because we didn't get those results very quickly, and we could not really gain experience through this process by taking this first document as a service and extracted this as a service and adding new features on top of it as well. So instead, we should have focused on smaller chunks. And so what we did instead with the next service, the next collaboration app that we used as a candidate for microservices, is that we split it in smaller chunks and going from top to down. So we have identified the next candidate for microservices. And what we did first is that we extracted the user interface first as a separate app, extracting the web client. And the business logic itself is at this step still residing in the monolith. And the web client itself is, the monolith is introducing a new REST API which can be addressed by the new extracted web client. So this gives us the advantage that we can develop and deploy the web app independently, and that we can iterate on the user interface very, very rapidly. So that's the first step that we did. The second step is then extracting the business logic. And that is more work than extracting the web client, because you also have to take care of the dependencies that it had before in the monolith. So for every dependency that you had in the monolith is that you have to specify or provide an API that on your new service. So for example, if the monolith is still accessing our new service, we provided, for example, a REST API could also be another one. And at that point, we are still accessing the same data storage, and that's the one that we are untangling the next. Because to become a standalone decoupled service, we finally need to split the data storage as well, so that our new service is becoming the data authority, or is getting the data authority of its own business functions. And in case that you are keeping redundant data that we did, for example, with our Drive app, like that we kept the author data redundant, is as soon as you do it, you have to keep them somehow in sync. And you, for example, and we did it by establishing a message broker. So whenever the redundant data has been updated in the monolith, an event has been submitted, and the consumer has been updating it accordingly. So when you're dealing with several candidates for microservices, you ask yourself, okay, which one shall I do first? Which shall I first address? And an easy principle is to extract those that are very easy to extract, because they have less or very few dependencies. And because when you start with those that are easy to extract, you are gaining a lot of experience in a short period of time. And so you are then also getting experience with microservices, but also with the extraction process in particular. And then you can also focus on those one that gives you the most benefit when extracting it through microservices. For example, if you have some services or some candidates that change frequently, then it's a good candidate to use it as the next one. And so then after you have created or you have converted it into microservice, you can then deploy changes faster than before. Another option is that you are extracting those that are using different resource requirements. For example, if you using someone with high memory consumption, you can deploy it on server with higher equipped memories, so you can scale your microservices world easily. And another thing is that you should stop feeding your monolith, because when you're carving out your services on your one side and you're adding new features or new functions on the monolith, then your monolith is not going to shrink. Instead, it's staying the same, or in worst case, it's even growing, and that slows down your transformation process. So the next thing is that I would like to address is establish a microservice ecosystem, and that might be kind of particular for us because we are running our services, our product, not only in the cloud but also on premises. We have large customers that require to run our services on their own machines, so we have also established an ecosystem. So the first is that after we have untangled our microservices, how do we address them? How do we access them from the internet, from the public internet, from the client, from the user interface? And one thing is we could directly access them through a user interface, but this runs into the problem that you are exposing some parts of your internal API that are usually related to your inter-service communication. And in case of your services are running on, hosted on different domains, especially with a JavaScript client, you have also enable cross-origin resource sharing. And also your client might do, in terms of, in case of retrieving information from several microservices, you have to do multiple round trips. And you also might have different clients, a mobile client and a desktop client, and they might have different needs. So what you can establish then is an API gateway to work as an adapter, as a single point of entry for your microservices world. And this one eliminates your course requirements, and because we are now running on one single domain, and it keeps your internal parts of your API inside of your internal microservices world. And in an API gateway as well, also handles like protocol translation and also provides caching mechanism. So our monolith itself was mainly implemented in Java. And we used for our ecosystem, we used mostly Netflix open source software and with the Spring Cloud libraries. And Netflix OSS provides a lot of frameworks, libraries to build your own microservice architecture and infrastructure. So Spring Cloud provides a very easy interaction with this with Netflix OSS, just with adding dependencies to your class path and annotate something. I will bring up some examples later on. So the API gateway is the first citizen of our microservices ecosystem. Now the next one is like the authorization service or the authorization handling. And securing a monolith is easy because you usually have a common security component which takes care of the authorization in your request handling chain and then propagates the user information to your subsequent method calls, and they can trust this information. In securing microservice instead is a lot more difficult because you have to figure out how services can trust each other, and you also have to avoid handling authorization in every microservices. This is something that can be handled by introducing a global authorization server, which takes care of this cross-cutting concern of authorization. So we established an Auth-Server to run as its own service. And our API gateway, so this Auth-Server assessing is providing access token that the user interface can use to access specific resources to address resources from the microservices themselves. And our API gateway in this context is been used as an OAuth token relay. That means that after the user interface has obtained this access token, it's publishing the access token along with the original request to the microservice itself. One downside is with this approach is that the microservice itself still have to check the validity of the token, and additionally have also to retrieve the user information. So this causes to higher load on your authorization service. So that could be also another approach that you introducing JSON Web Token instead. To decrease the load of the authorization service, you have to eliminate the token validation and also the retrieval of the user information. And we could instead carry the user information as an identity claim and a JSON Web Token. In addition, this JSON Web Token is automatically be signed by the authorization service so that the microservices themselves can trust this information. The API gateway works as a token translation. So what it does, when the user interface, your client, requests an access token and after it has obtained this access token, it sends this token along with its request to the API gateway, and the API gateway does do the translation. So it extracts the access token and uses this one to the sends this to the authorization server, receives a JSON Web Token, and publishes then forwards those JSON Web Token along with the request to the underlying microservices, so that the microservices themselves only have to process this web token, which is quite easy to implement. The next citizen of our microservices ecosystem is the service discovery, and a microservice architecture can contain of a large number of microservices and interacting with each other. So how can services easily identify all the running instances it would like to interact with? A manual configuration is totally impractical and is very brittle, and so a service discovery instead provides a single lookup service where each service instance is registering itself automatically at startup. And other services can discover those, retrieve those already registered services and discover them, and then afterwards connecting to it. So some solutions are, for example, Netflix, Eureka, Consul, etcds, or Zookeeper. And we used, in our case, we used Eureka because it's together with Spring Cloud, because it's really easy integration. It's very, very easily integratable, because it's you only have to provide the respective dependencies to your class path and annotate on the one side your service and on the other side your service, your clients that then automatically register at startup. The microservices that want to use our service itself can also create on their side, for example, a load balanced REST template, and I come to this one later, and use the service ID and to the related REST template method to connect to your service. So, and what happens in the background is that the load balance REST templates connects to Ribbon. That's the client-side dynamic load balancer to discover and to connect your services automatically. So that's the next citizen of our ecosystem that introduce a client-side load balancer. Traditionally, load balancers are server-side components, and the client-side load balancer itself is part of the client application. And so it makes itself aware of what services are available and makes its own choice, like what service to call at any given time. So we also, in the service discovery slide, I was talking about the load balanced REST template, and that it automatically connects to Ribbon. And well, what Ribbon itself, it's a client-side load balancer, and also from the Netflix OSS family. And what it does is it automatically integrates with the service discovery to obtain the server list, and it uses Eureka when it's present on its class path, and load balances automatically if multiple service instances of our microservices are available. So there is no implementation code, it's all client-side, and you don't need a server-side configuration. When carving out services, you have to in a distributed system, you have to face the fact that you have to challenge, we have to face the challenges that we are interacting over a slow and unreliable network. So we have to make it more resilient, we have to design it for failure. That meaning that we have to introduce timeout handlings and have to provide fallbacks and also the circuit breaker pattern. And what the circuit breaker does, we implemented is with Hystrix, another family member of the Netflix OSS. It monitors every remote call that you defined as a Hystrix command, and it tracks every request and creates and counts the number of successful and failed requests that you did. And at a specific threshold, the circuit breaker itself, it opens and returns a failure immediately. It could be, for example, a failure, a fallback that you have previously defined, or an exception as well. So it's a fail-fast strategy. I have to make it a little faster. So this happens client side as well, so you don't need a server, you only need specific annotations to it. So you define a Hystrix command and define a fallback method if you want to. And you are then automatically Hystrix is then monitoring your remote call. And what is also very important is that you don't forget to set your timeouts as well, because this is something that Hystrix does not care about, but is taken care of. Instead, you have to set timeouts as well. And what Hystrix does, it does emit for every occurred event and its current states an activity stream, which can be displayed as through Hystrix dashboard. That's kind of a monitoring web interface, which allows you to monitor your services on service level. So you still usually have monitoring on a monolith on server level, and Hystrix dashboard together with Turbine, that's another tool of the Netflix OSS, allows you to display the services, the status of each service, and consolidate the view itself. So the current ecosystem, what we have covered so far is an API gateway, authorization servers, service discovery, and monitoring dashboard. And you might think, well, we are done, but that's not the case, because there are a lot of more to cover. For example, central configuration management that you can establish, or logging analyzing for debugging, for example, that you can log across service boundaries. And what's also very, very important is the build process and this continuous integration, continuous delivery pipeline, which you already have in your monolith, but now you have to apply it per microservice. And since the fact that you are dealing with APIs now more than before, you have to extend your testing with consumer-driven contract tests. Then you have to make sure that you have a fully accessible environment for your development, that you don't have to take care as a developer for setting up all these services themselves. So the lessons that we learned is that during our journey, and we are not there yet, so we are not at the end yet, so it's that starting with decomposing in big chunks frustrates, because it takes a long time before you get something done and you receive a result. And yes, establishing your ecosystem takes a lot of time and requires a lot of new skills and tools. And so we started at the very beginning with no explicit infrastructure team, and it was slowing down the process because each team was kind of finding their own solution, and so it was slowing down everything. And what also helps, and which we didn't have at the very beginning, is a holistic picture of the target architecture, because it keeps you focused on what's to do next. And well, in the end, it took a lot. Will take far longer than you originally anticipated, because you are now going into this completely new world. So as a summary is that what we can derive from our learned lessons is that it's better to start small and split in manageable steps, so service by service. Instead, what we did in the beginning was kind of mistake that our chunks were too large. And establish teams, that's for microservices that we already did with our collaboration apps, but also for infrastructure, because that's the ecosystem has to run, and you as a developer don't want to take care of the ecosystem all the time. Instead, you have to have that's our experience that we made, an infrastructure team as well. And also define a target architecture to stay focused on what you want to achieve next. And well, yes, it's even though it's still a long way to go, we can say that it's possible to transform a monolith into microservices even with limited resources. And so having said this, not only our product, but also our software architecture was made with love, sweat, and tears a lot, and now also with microservices. Thank you.